Similar design patterns we are means we have been discussing it. So, uh, can we talk about interpreted? If it is interpreted, then I believe it is obvious that in similar design pattern, it would be composite design pattern. So, interpreted design pattern, composite design. Okay, so the design pattern, if we see the 23 design pattern, their main focus is on inheritance and containment. Okay, polymorphic can be both, like we saw that inheritance can be virtual inheritance. So inheritance can also be polymorphic. Otherwise, inheritance considered as equivalent to a composite kind of containment. Okay, anyway, we'll talk about interpreted design pattern. So uh, if we see something that is continuous, means repeatedly we see something like 2 plus 4 divided by 2 plus 2, 2, or probably I can make it simple, 2 plus 2 divided by 2 plus 2. Okay, if that is the case, then that would result into 5 because division would take place prior to the addition. 2 into 2 divided by 2 into 2. So that would result in 2 into 1 into 2. So wherever 2 plus 2 multiplied by 2 division by 2. So that would result in 2 plus 2 multiplied by 1 because division will take place first, then multiplication, then addition. So this is the, so whenever we see kind of a mathematical uh, expressions, so in numerical expressions we see it's a common thing everywhere, like division take place first, and then multiplication, subtraction, and then addition at the end. So this is what we see in any numeric computation. So can we interpret it? So if I see any numeric expression, then can I do some interpretation based upon some algorithm because it's fixed. So when we have kind of some kind of domain, and inside the domain then we have a language. So this is a language. In language we have my division first, then multiplication, subtraction, and then addition. Then inside the language, then we have the language is English also. Language is Russian, language is Arabic. Okay, so mathematics is a language. Inside that language, we have a grammar. Okay, so inside the grammar, what we are doing is that we are doing division, multiplication, subtraction, and addition in a kind of priority manner. So, if this kind of scenario, when we are seeing where there is a domain, there is a language, and there is a grammar, then it leads to interpreter. So, if English is a language, then there is a grammar that noun would come first or verb would come first. So, there are many terminology, adjective, pronoun, preposition. Okay. So, if these are the terms, then which will come first and which will be interpreted next. So, there is a grammar for that. If that is the case, like we talked about mathematical and numerical expression, there is a grammar for that. If that is the scenario, then it leads to a design pattern. Means it leads to a kind of mathematical fixed way of computation. If that is the scenario, then it lands up into a kind of interpreted design pattern. So in interpreted design pattern, we see what are the things that we kind of do. So we do division, multiplication, subtraction, and addition. Okay, then we see that when there is a division, then there is a left side to it and right side to it. There is a addition, multiplication, there is a left side to it, right side to it. So if I see division, then we don't go for whatever is the left side numeric and whatever the immediate right side numeric is there, we compute immediately. But if it is addition, that is the least priority one, we see complete whole left and complete whole right, because addition has to happen at the end. So if there is addition, whatever is there at the left side complete expression, whatever there on the right side complete expression must be evaluated first, and then addition will come at the end. Whereas it is division, then immediate numeric left, immediate numeric right will divide immediately. So there is a grammar kind of rule. So what we do in the mathematical grammar is, if we have this kind of mathematical computation operators plus or mathematical kind of computation terms as plus, minus, and this kind of thing. For that, we can have separate class. So we call it leaf classes. Means they do the actual work, but we need. So there is a class called addition. There is a class called multiplication, subtraction, and then addition. So if I pass the expression to division, then wherever division is there, immediately it will kind of do the computation, and it will make it small because that computation is done. Then it will pass to multiplication. Wherever multiplication is done, it will do the computation, it will become small, subtraction, and then addition. So these are the worker classes, I mean they work. But at the end, we need a class which would kind of do some operation. So if kind of if there is addition, then full left side and full right side will go for the computation. Then full left side again, if there is addition, then full left side of addition. So we need kind of a operation. So whatever the operator mathematical operators are working, one manager kind of stuff comes into the picture, which calls these mathematical operators. Okay, but there is a difference. If we look for the operation which assemble, if it is addition, then left side and right side, then left side again it go to the same way of processing. Again left side of the plus, right side of the plus. Then again left, again go for the processing. And then again left side of the plus, right side of the plus. If there is no plus, then left side of the minus, right side of the, again left side would go for the processing. Again if there is no minus, then left side of the multiplication, right side of the multiplication. So this leads to two steps. One, it is recursive. So if we are talking about an operation over mathematical kind of symbols or mathematical operator, one operation manager, then it is recursive. Whenever it sees, like for a positive operator, then full left side and right side it takes as one, and then left side again it process it, where again it finds plus. If it is not there, then minus, then again left side. So it is doing its own work again. So it leads to kind of a recursive classes, means class object calls itself till it finds that there is a division. So there are two things, it divide and get the result. Okay, so we can kind of so there are, so this is one thing. So two things we find. One, we find that the operation what we do on the operators, operations are recursive in it. One thing. Second thing, that if operations are recursive, then operators are non-recursive. So there is a leaf terminal, there is a terminal class which receives the two operands, and then it will do the computation. Whereas this is leaf, there is a terminal expression. There is one composite terminal class, there is one composite class. If it receives two expression, then left expression again it will pass to itself or to anyone who can handle it. So there are two kind of class we see. One is terminal class and one is a composite class. So this leads to a recursive class. This leads to a design pattern called composite design. So in composite design pattern, we have a class, and that is a kind of interface class. From the interface class, we derive leaf classes or terminal classes and again a composite class. Composite class contains or aggregates the interface class. Since it aggregates interface class, there is chance of the so there is interface class. From the interface class, terminal classes are derived and composite classes are derived. Composite class, they aggregate the interface class as a member variable. If they aggregate the interface class as a pointer, then they aggregate any terminal class because they all they kind of conform interfacing. So they aggregate terminal classes and they aggregate themselves also. So this leads to a composite design where where a class aggregates its base class as a pointer, and since it aggregates its base class, so it aggregates itself or anyone who derives from the base class. So this leads to a kind of a composite design. Okay, we talked about composite design pattern. So in composite design pattern, we have an interface class, and then against the interface class, we have two kind of classes that derives from it: the terminal classes or leaf classes and composite classes. Composite leaf classes, they do not aggregate anything, but composite classes, they aggregate interface base class, interface class again. Now, since they aggregate interface class again, so they can contain any leaf classes or themselves or any composite classes. Then this story would go indefinite, like directory. If I have a directory, then directory contain files. Those are the leaf nodes. But it can contain directory again, means subdirectory. Now inside the subdirectory, if we go, then it can again contain files and it can again contain subdirectory. So this story keep on going till a directory contains all the leaf nodes. So this is the story of the composite design pattern. Now composite design pattern falls in a structural design pattern, whereas interpreter design pattern falls in behavioral design pattern. So that is the difference. So we'll proceed through the example what we have taken as operator in interpreter design pattern. Like I have a class called interpreter, and from there we derive addition, subtraction, multiplication, and division, and expression. There is a composite class called and expression. Now, if I pass two expression to the and expression, the first expression it would try to resolve. So it would pass interpreter. So interpreter has a function called execute, and interpreter is a base interface class. It has a function called execute. If execute is called, okay, it takes expression 1 and expression 2, and then division, multiplication, subtraction, addition, they have execute, and they realize the execute as expression 1 and expression 2. And there is a composite class called and expression, and it takes two expression. The first expression what it sees, then it tries to execute it again. If it is again a composite class, it calls its itself execute again. Or if it is a leaf node, then any of the leaf nodes execute get called. So this way it keeps happening till both operands are leaf operands and it gets executed. Now how we set the grammar, that is the question. Now when there is an interpreter, we first set the grammar, because if I have if I have a division, a multiplication, subtraction, and addition, then in different contexts priority can be different. Means my mathematics is a way where I want kind of a plus to happen first. Means this is why the priority. So inside the and expression, the grammar would be different. So we set a grammar. Like I say, and expression to take two expression to be executed. So and expression, and inside the and expression, we set two operands as again and expression. Again inside the first and expression, we have addition and we have division and multiplication. So AND expression takes two expressions. First is again one AND expression. Second is again one AND expression. The first AND expression is again AND expression of division and multiplication, whereas second AND expression is AND expression of subtraction and addition. So now leaf operations are coming. Now if I have a big set of computation 2 plus 3 plus 5, then minus 3 multiplied by 16, then division by 20, and then I have a kind of a string of 1000 operators. Now so this one, whatever we see, this I pass it to the kind of the whatever the grammar we have set as AND expression, a composite. There, as both expression 1 and expression 2, I said execute this. Expression 1 and expression 2 both I pass this and say please execute this. What it would do is, because the grammar is set like, first it will go with the left hand expression, right hand expression, and it would try to do AND. Now in the left hand expression, then it will go again, and then it will do again left hand operation and right hand operation. It will keep doing till it finds left hand as a division and right hand as kind of whatsoever. So division will come into the picture first. So it will go for division as a kind of to do the thing. Division, if it receives the expression, then it would do the division and return the result. Whatever the result is, it will go for the multiplication. Whatever comes out finally from the recursion, then it will go to second AND expression where it is subtraction and addition. There it would do again go inside, then it will try to do all the subtraction. Whatever result comes in, then it will try to do the addition. Okay, so this way, if we make this kind of grammar where we give the priority to the division first, and then all division once happens, then whatever comes out, then with that we do the multiplication. I mean, I have set like this: the division and multiplication is one expression, subtraction and addition is one expression, then combine two as again and expression. So division and multiplication one, subtraction and addition one, they come together, then these two as AND. So this is the grammar I have set, and but anyone can set anything whatever comes to mind if it fulfills the mathematics. Now if the mathematical the string what we pass there and it forks it, okay, we may not, so we can kind of start with simple interpreter execute also. So instead of going with the composite kind of class execution, interpreter through interpreter, that is base class, I can make a grammar and I can say execute. There it can start with the AND operation wherever it starts the fire. So then it will start doing. So grammar, whatever grammar at the beginning we make, through that grammar it will start doing the recursion. So that grammar is required. Now if we come to composite design pattern, that is a structural design pattern. So there is no grammar. Okay, like directory contains file and directory. Again, directory contains file and directory. It's a structure. Okay, so if I pass a kind of directory, so there is a directory class derives the file and directory aggregates directory, file and directory aggregates directory itself. Now if I say that kind of traverse directory and I give a path, then directory would start traversing it. Okay, so whatever it, so it would kind of, it may break the full path with the forward slashes, and it would take out all the kind of tokens, and then it would start doing the whatever is the directory. So directory it would handle first. So whatever is directory, then again it will go in recursion, and it will start doing till it reaches the last directory, the end directory where there are files. It would print the file directory name, it would come out, and then again it would fill. So this way, it would iterate the whatever it receives, and till iteration till goes in recursion till it finds everything as a file. So if we see the composite design, so the structure, the kind of the tree structure rather we say, so tree structure we make in the composite design pattern also, tree structure we make in the interpreted design pattern also. But in the composite design pattern, which is a structural design pattern, it is a tree structure. It is a tree structure at all. So main intelligence comes into the picture when we start executing the composite class. So in the composite class, it it just behave everything as a structure, is a kind of a list of a structure, and it execute as a list one. So there is no intelligence. I mean, so we can make intelligence. Please go to the about section of the YouTube channel, and there you will find a website. There in the training you see the design pattern, and there go to the interpreter and composite design pattern. So through composite design pattern in a structure also we can do some kind of a smartness, but still composite design pattern that comes in a structural design pattern, it's a pure structure. How we structure it and we iterate the structure. So it leads to containment behind the scene. And since it leads to containment, then story comes to attributes. But where in the behavioral design pattern, interpreted design pattern, okay, it's not the structure. If we see division, multiplication, subtraction, and addition, there is a fifth guy, that is and expression. So and expression is doing the operation on the operators. So operands, okay, how to assemble the operands and do the mathematics, that is an operation. If there is operation, then there is more intelligence required. There is a behavior. If that is behavior, then it falls in, okay, in behavioral design. But where we talk about a structure only, attributes, not the operation, then it falls in a structural design pattern. So a structural design pattern, okay, so main focus is given on kind of creating the complex structure the way composite design pattern, where in behavioral design pattern we see the runtime operation. So runtime operation comes into the picture, then we see inheritance polymorphism mostly. Whereas the structural runtime comes into the picture, then we see generally the containment polymorphism. So that is the difference. But anyway, we understand the interpreter, that we see the composite design pattern in the interpreter through operation or through a grammar, whereas composite design pattern is a pure structural design. Please browse through the website, and we that is something that you will never find in any book. All the examples what we have, there is a disclosure also, two disclosures, and all the examples, one kind of design pattern we have grouped into many categories, and there are many examples. There are few examples that are taken care by many design pattern. How this will happen if it happens through interpreted design pattern, how it would happen if it happens through mediator design pattern, how it happens if it happens through observer design pattern, how it happens if it happens through bridge design pattern, how it happens if it happens through composite design pattern, how it happens if it happens through strategy design pattern, how it happens if it happens through template method, how it happens if it happens through the visitor design pattern. So this way, command design pattern, chain of responsibility, same example. So this you will not find anywhere. Okay, so that is the story. So when we talked about the behavioral design pattern in the interpreter, then someone is it is talk about operation. So it is now understood that if there is an interface class and there is a derived, that is a composite class which aggregate the interface class, then whatever the methods there we are declaring in the interface class, they become template methods that will be fulfilled by the realized by the derived classes. So that is fully kind of it's really behavioral design pattern, interpreted design. So that should be seen.